Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, do consider subscribing. On this video, we are going to evaluate composite functions graphically. So let's roll it. In this question, we've got the two functions. F of x is given in red. Okay, that's a red graph, and g of x is this black graph. And we are asked the question, determine if f of g exists. F of g is the composite function f of g of x, where gx is the inside function and f of x is the outside function. Determine if f of g exists. It's a very interesting question. It's almost like saying, is it even possible to make this combination f of g of x? And to understand whether it's possible or not possible, let's take a look at the schematic understanding. Now, this is g of f. If this is the domain of f and this is the range of f, then the second function, f is the first function, the second function g, its domain includes the range of f. And that is then mapped to the range of the composite. Okay, so this then becomes the function g of f of x, where f of x is the inside function. This clearly means that the domain of the outside function g in this case must contain the range of f, which is the first function or the inside function. Look at this. The range of f becoming the domain of the second function g. And that means that the range of f must be a subset, must be contained within the domain of g. That would be the condition for g of f of x to exist. And in the same way, if you're looking for f of g of x, f of g of x, where g is now the inside function, there the condition would be that the range of g must be a subset, must be contained within the domain of f for a combination such as this, the composite f of g of x, to exist. And we are going to use these criteria to determine if the composites are possible or not. So let's get back to our question. Let's find the domain of each of them, domain and range for both of them, f and g. All right, so I'm going to write d of f, the domain of f. The domain of f, the red graph, if I look along the x-axis, the domain of f should be between 0 and 6. And the range of f would mean along the y-axis, I'm looking along the y-axis, would be -1 to 5. Okay, domain looking along the x-axis, range looking along the y-axis. For those of you who haven't seen my video on domain and range graphically, the link will be somewhere up there. I will also mention that on the description below. Go ahead and take a look at that. Okay. In the same way, domain of g, the black graph, again looking along the x-axis, should be 0 to 5. Okay, going along the x-axis for the graph in black, and then the y values for g is up until 4, so that the range of g can be written as 0 to 4. Okay, now we're looking for f of g, g of f of g. First, let's consider f of g of x. F of g of x. All right, g of x, the range of g is the 0, 4. Is it contained in the domain of f? 0, 4 clearly is a subset of 0, 6. Can you see that? Range of g, domain of f. Clearly, since 0, 4 is contained in 0, 6, we can say that f of g of x exists. Now, how about g of f of x? Okay, g of f of x. So we need to look for the range of f. Range of f is -1, 5. Domain of g, that's 0, 5. Whoa, -1, 5 is not fully contained. So I'm going to put a red cross around that. It's not contained in 0, 5. Can you see that? And because the range of the inside function is not fully contained in the domain of the outside function, we can conclude that g of f of x does not exist. All right, let's look at the question where we are asked to evaluate or find the value of the composite function, but that is given graphically. All right, so the question is to find the value of f of g of 1. You're given two graphs. F of g of 1 means first we start with the inside function. Inside function is g. So first identifying the graph of g, that's the graph of g. G of 1, so we're looking for 1 along the x-axis, 1 along the x-axis, the domain. And you read g of 1 happens to be 3. So g of 1, I'm going to write it here, is 3. That becomes the input for the outside function. So we are going to find f of 3 now. And because it's f of 3, we have to go to the graph of f and we look at 3. And as we look for the value on the graph of 3, we will get f of 3 as 6. That should be our answer, and we'll put that as 6. So we can say the value of f of g of 1 is 6. So that is how we evaluate a composite function graphically. Let's take one more example. In this question, we have to find g of f of 2. In this case, f of 2 is the inside function. So we make our way to f, the graph of f, and it was f of 2. So the input is 2. Look along the x for the input, and the output vertically, that's 5. So f of 2 is 5. That will become the input for g. All right, so you have to find g of 5 now. So we're looking along the graph of g at 5, and that value here is 3. So the value of the composite function g of f of 2 is equal to 3. What did we do today? A very, very important condition. We came across a very important condition saying that the range of g, again, use the word input and output. The output of the inside function must be contained in the input of the outside function. Only then are composites possible. And then we saw a very interesting way to evaluate composite functions graphically. Again, start from the inside function first, and you'll probably know how to read graphs. I think that should be a very interesting way to do composite functions graphically. Evaluating composite functions graphically actually deepens our understanding of composite functions. We begin to literally see what that phrase, output of the first function, what that phrase actually means. And that helps us realize that any two given functions at random, you can't just compose them. You need to first check their domains. I'm going to see you in the next video.